SolidWorks Simulation, Lecture 16, Flow Simulation, Part 1, Water Flow through a Pipe. For the preparation step, load the software. Flow Simulation. For the second preparation step, load the toolbar. There are 5 toolbars for flow simulation. We'll choose main toolbar, and this is the main toolbar. We'll open the project or study. This is the project name. And since this is an internal flow, we need to define 2 lids so that the boundary of the flow is defined. So we create 2 lids or cover so that the boundary of the flow is defined. So we have 2 lids created. So now we can see that we have finished with the first step. The second step is the initial condition using a wizard. Step 3 will be the boundary condition. Step 4, the goal. The goal defines what we need to know or what we will have for the result. Step 5, run the procedure. Step 6, result. So this is 1, 2, 5, 3, 4, 6. Okay, so we go for the second step, initial condition using wizard. The project name, we use the default name. The unit, use the default units. And this is an internal flow. So the default is internal flow. The water flow inside the pipe, internal flow. And there is no heat, no radiation, no transient, no gravity, no rotation. And the direction of flow will be in Z direction, in this direction, Z direction. So I'll change the flow direction as Z direction. And the default fluid will be water. Add water. Next step. And the wall will be adiabatic. No heat flow through the wall. And the roughness will be perfectly smooth. The roughness will be 0. And this is the 1 atmosphere pressure, 20 degrees C. And these are the velocity of flow for external flow. So it is not applicable in this condition. And before we finish with the second step or the initial condition, we'll go back to see that in the second step we define the direction of flow, water as the fluid, and leave the others unchanged as default. So the second step, we define the direction of flow as Z direction, and the fluid will be water. Step 3, boundary conditions. Insert a boundary condition on. Make sure that you choose the internal surface instead of external surface. The surface that came in contact with the flow. So not this surface, the internal surface, which is in the surface in contact with the flow. So this page is velocity and mass flow rate or volume of flow. This page is for pressure, and this page is for condition of wall. So we will choose page 1 and define inlet mass flow as 0.5 kilo per second flow, the inlet flow. So we have finished with the first boundary condition, which is 0.5 kilogram per second inlet mass flow. So we define another boundary condition, insert, and we define pressure, environment pressure, as 1 atmosphere pressure at 20 degrees C. So this is the atmosphere pressure and temperature. So the boundary conditions will be an inlet mass flow rate of 0.5 kilogram per second, and the outlet will be 1 atmosphere pressure and 20 degrees C. So we have finished with the third step. For step 4, goal. Goal defines what we need to know in the result. So we'll choose average pressure and average velocity. And for the inlet surface, since we have already defined the mass flow, so we will let it calculate pressure and velocity of the inlet surface. For the outlet surface, we have already defined the pressure. So for the outlet surface, we don't have to calculate pressure. So there's only velocity. So now I have already defined the goal, which is the thing that I want to know for the result. So this is the step 4. And step 5 will be run the procedure. And it takes a little bit of time to run the procedure, so I will stop recording. This is the iteration of the procedure, and this is the plot, and we can change the properties of the plot by rotating the plot. And this is the temperature, so I change to maybe pressure or velocity. But the procedure is finished, so I may not be able to display the result because the solver is finished. So I'll click finish. So this is the result. First of all, I'll show a cut plot, insert the cut plot on the YZ plane for velocity, and this is the velocity. And I'll also create a cut plot on XZ plot, XZ plane for pressure. So this is the pressure distribution, and this is the velocity. And we can also play the animation for the cut plot. So this is the animation of the cut plot for velocity distribution and pressure distribution. Now we can hide the plot. Now for surface plot, we can insert a surface plot. We can choose all surface, pressure distribution, and this is the surface plot. You can also plot velocity plot for surface plot. I'll hide the plot. And for flow trajectory, flow lines, I'll choose inlet surface and outlet surface. And I'll choose lines, 30 lines, to show the velocity field. So this is the velocity field. But we can also show the flow line using different representations. For example, arrows. And we can make the arrows larger. So this is the flow line, and we can also play the animation for the flow line. We can also change the properties from velocity into pressure distribution, and the color will be the pressure, and this is the animation. We can also tap the result by point parameters, but we'll leave it until future lectures. So this is the first lecture for SolidWorks flow simulation, and we talk about the 6 different steps for running a SolidWorks flow simulation. The first step is to draw a 3D model and create a new project, and maybe create 2 covers or lids. The second step is the initial condition using Wizard. The third step is the boundary conditions, inlet and outlet condition. Step 4 will be the goals. Step 5, run this procedure. And step 6, the result.